starting off, we have an electrical resistor. It's got 500 ohms plus or minus 10%. What is the highest value its resistance could have within this tolerance range? So we can find the highest and lowest if we wanted to, but the highest is going to be the plus 10%, right? The lowest would be the minus 10%. How would we find that? Well, if it's plus 10%, that means we're going to think of it as 100% plus 10%, which means 110%. So we're going to look at what is the new value that's 110% of the original value. And the original value is 500, or you can think of this as 100%. That's going to be our base. 500 equals 100, right? 500 goes to 100. And if 100 increases to 110, then 500 increases to what value? It's obviously going to be bigger than 500. And we want to cross multiply and divide. We get 100x equals 110 times 500. 55000 divided by 100, and we get x equal to 550 ohms, which is capital Omega. So that's the highest value in this resistance tolerance range. You can do the same calculation. The lowest will be 450 ohms. All right, here we are cutting up some sheet steel. 2 square feet of sheet steel is wasted for every 16 square feet used. What is the percent waste? Well, we're looking for what percent is 2 square feet of 16 square feet. 2 over 16 equals x over 100, right? If this is the percentage that 16 is, then 2 is going to be what percentage of that? It's going to be a smaller number, right? 16 gets smaller, so 100 is going to get smaller. All right, cross multiply and divide. 200 equals 16x. And we get 12.5%, which is quite a bit of waste. But that means 12.5% of every amount that you're using for the certain cutting operation that they do is going to lose. It's going to lose 12.5% of the amount you have. So you have to make sure you increase the starting amount by 12.5 to get the exact amount that you want at the very end of the product. All right, here we have a carpenter buying some tools. We have a 15% discount on orders of $100 or more. And the carpenter is buying some bits at $100, a caliper at $40, and a 7-piece ratchet wrench set at $60. So what's the total amount? Well, it's going to be, you can do 99.99 plus 39.99 plus 59.99. It's actually faster to think of this as 100 plus 40 plus 60, and these are all just 1 cent off. So all we're going to do is subtract 3 cents from this. 100 plus 40 plus 60 is 200, minus 3 cents is going to be 199.97. If you do this in a calculator, you're going to see that you're going to get the exact same thing. Okay, so we have a total cost of $199.97, and we know that this is in fact more than $100, right? So we're going to get a 15% discount on it. A 15% discount is like saying we have a 100% price, which is our $199.97, and we're taking off 15% because it's a discount. It's taking it off. So our new price, our new amount is going to be 85%. So if our whole is $199.97, which goes to 100%, and that changes to 85% of its new amount, and that means this is going to change to a smaller X amount. That's what we're trying to find here. So let's go ahead and cross multiply and divide. 85 times 199.97 equals 16997.45. And we divide by 100. Now, of course, this is a dollar amount, so we need to make sure we round to the nearest cent. 169.9745. Round to this place, right? Because that's the nearest cent. So we have x equal to 169.97. And that's the dollar amount. That's a 50% discount on the total price, or around $200. Okay, here we have a welding shop charges 185% of its labor and materials to cover overhead and profit. So the actual bill is $822.51. Now, what is the cost of labor and materials? So you may want to say, well, what's 185% of 822.51? That's actually going the other way. We want to go smaller. The bill that the welding shop charges the customer is $822.51. That means $822.51 is 185% of the actual labor and materials cost. So 822.51 is going to be our part because it's bigger than 100. And we know that goes to 185%, right? These two things are the same amount, just one's a percentage, one's a dollar amount. This, of course, is over 100. And we're trying to figure out what is the actual cost, which is going to be a smaller number than 822.51. So as 185 goes down to 100, right, this goes down here, 822 will go down to a smaller amount, which will be our actual costs of labor and materials. Cross multiply and divide. It gives us 822.51 equals 185x. Divide by 185x, or sorry, just 185. It's going to be a dollar amount in the end. We get $444.60. So the original cost of labor and materials is $444.60, and that is increased to cover overhead and profit by 185% to the total of $822.51. Here we have a truck design that's can improve fuel economy by as much as over 45% over older square nose rigs. So the aerodynamically designed truck can get better gas mileage. If a trucker currently gets 4.5, what mileage could he potentially achieve in the aerodynamically designed model? Another way of thinking about base and part is original and new. Base would be the original, part would be the new. So we're going to kind of think of it like this. So 4.5, this is going to be our base. That's the original amount, base or the original. And we get an increase, right? This is an improvement of 45%. So an improvement means that we go from 100%, the original amount, and we add on to it 45%, which gives us 145% for the new fuel economy, right? And that's what we're trying to figure out. What is the new mileage? What's the new fuel economy? That's going to be our part. This will be X here. For a new fuel economy over the old fuel economy, or the original one, I should say, is 145% greater than, well, it's 45% more than the original. So 100 went up to 145, 4.5 will go up to some specified amount that we're trying to find. Cross multiply and divide. 145 times 4.5 is 652.5, and divide by 100. Giving us 6.525. This has got, it says round to the nearest tenth here. which is this space right here. We look at the 2. Is it 5 or greater? No, it's not. So we do nothing to this. We just drop it. We can just ignore it and say we get 6.5. My MPG, they also use miles per gallon. Same quantity. 6.5 is our new gas mileage. All right, here we have a worker that's got a pay cut of 10%. She had made $20 per hour. So she lost 10% off $20 per hour. And now we need to ask, what is her pay increase to regain the $20 per hour? Now you might think, well, she just needs a 10% increase, but that would be incorrect. And you'll see why when we do the actual proportions. You could do this in one proportion. I'll show you how to do it in 2 steps here, because I think it's a little bit more kind of clear. First, what is the pay cut amount? She lost 10%, so she lost 10% off of 100. I'll write the percentages in there. That means she makes 90% of her original pay $20 per hour, I should say. So this is the original for this first proportion. So we have $20 per hour. Per hour becomes X dollars per hour, equaling 90 over 100, right? 100 went down to 90. 20 is going to go down to some amount. Cross multiply and divide. We get 100x equals 90 times 20, which I believe is 1800. Yep. Divide by 100 and we get $18 an hour. So she lost $2 an hour by doing that. Now, what must she do, or what percent increase must she get now to regain her original $20 per hour wage? Well, we can do the same kind of process, right? We're looking for, now the original, quote unquote original, is $18 an hour. And that's going to be our 100%. We're trying to figure out what percentage, right? That's going to be our X there. We know we're trying to go to $20 an hour. We're trying to figure out if 18 goes to 20, what must this percentage go up to? So cross multiply and divide. 20 times 100 is 2000 times 18x. Divide by 18. And we get 111.1111, and it continues on. You can just do 111.11. What does this mean? This means that she must get an increase of 11.11% increase is needed to regain $20 per hour. It's not the 10%, right? If you make less money, you have to get a bigger increase to get back to what you originally started with. That's why it's kind of a big deal to take a pay cut. It might take a lot longer to get back to where you originally started than you would think. All right, here we have an interesting kind of newspaper chef restaurant thing. It was a challenge to reduce the calories of certain meals in each restaurant. And the goal is to reduce it by 25%. So all we're trying to do is figure out which one actually achieved its goal of reducing by 25%. This is actually quite simple to do, but we can set up the proportion. You don't need to set up a proportion to do it. But we'll do that because that's what we've been doing. So the original, right, versus the new, this is going to be our base. This is going to be our part. And all we're trying to figure out is what is the new percentage for each of these things. And it's going to be less than 100, and we're trying to figure out, is that 25% less than 100? Or in other words, is it 75% or less? I'll show you that. So we have our part. I'll do restaurant A first, 322 over 559. equals x over 100, right? If this went down to 322, then 100 is going to go down to this percentage here. Cross multiply and divide. 100 times 322 is that, 559x. So x equals, let's see, 32200. We have 57.60. I'm going to round to 2 decimal places. Now, is this a decrease of 25%? It is. We can see that by taking 100% and subtracting 57.60. This tells us how much of a decrease it is. And that'll give us 42.40, I think. Yep. So restaurant A decreased its menu item by 42.40%, which is almost, I mean, that's almost half of the original calorie in the dish, which is quite impressive. Okay, let's move on to restaurant B. Same process, right? We're going to take 200 over 276 equals x over 100. Cross multiply and divide. Divide by 276. Now we get, make sure I have zeros in my 20,000. 72.46%, which if you take 100 minus 72.46, we get 27.54% reduction. And so that one also completed its goal. All right, last problem. 674 over 864 equals x over 100. Cross multiply and divide. By 864. And we get 67400 divided by 864 equals 78.01. I'm rounding to 2 decimal places. And that is a reduction of 21.99%, which almost made the 25% reduction. So restaurant C is the only one that didn't quite make the challenge, but it still did a pretty impressive reduction of 22% pretty much.